Derivatives with logarithms, chain rule, Leibniz's notation. So here we have our function log a to the base of a x. We derive that, we get 1 over x multiplied by ln of a. I'll do an example of this in a second. It won't be the chain rule, I'll just show you how this works a bit better. But here's the chain rule. When you have x within u and u within y, when you have a function within a function, and this is the derivative of having a function within a function. Show you that example. Let's say we have y equals log 7x. The derivative would be 1 over x ln 7. So you have you have a log to the base of a number x. Then you have, when you derive that, you get 1 over x multiplied by natural logarithm of that number. Let's try a second example, an example that involves a chain rule. Y equals log 10 x squared plus 1. Here we have our inside function, x squared plus 1, and the outside function, log to the base of 10 of x squared plus 1. We can label u as x squared plus 1 and y as log 10 of u. Derivative is derivative of y with respect to u multiplied by the derivative of u with respect to x. So we need to find the derivative of u with respect to x and the derivative of y with respect to u. The derivative of u, x squared plus 1, is just 2x, and the derivative of log to the base 10 of u is 1 over u ln 10. Just like before, you have log to the base of a number of u, you end up with 1 over u natural log of that number. It's just how it works. Filling this in, we get derivative of y with respect to u, 1 over u ln 10 multiplied by derivative of u with respect to x, 2x, and what we end up with is 2x over, we'll sub in u, x squared plus 1 ln 10. And that there is our first derivative of this up here. Let's do another example. Let's say we have log to the base of 3 e to the x. The inside function is e to the x, and the outside function is log to the base of 3 of e to the x. In that case, we can call u e to the x, and y log to the base of 3 of u. The derivative of y with respect to x equals derivative of y with respect to u multiplied by the derivative of u with respect to x. We need to find the derivative of u with respect to x, and we need to find the derivative of y with respect to u. Derivative of u, ex, just becomes ex. I have a video on this if you don't understand, but that's just it, basics. And the derivative of log to the base of 3 u is 1 over u ln 3. Just like before, same rule. if we're filling this in, we get derivative of y with respect to u, which is 1 over u ln 3 multiplied by derivative of u with respect to x, ex, e to the power of x. Simplifying this, we get e to the power of x, u being e to the power of x multiplied by ln 3. We can cancel out both ex from the top and bottom, and what we're left with is 1 over ln 3. Simple as that. And for our last example, let's say we have log to the base of 4 ln x. Our innermost function is ln of x, and our outermost function is log to the base of 4 of ln x. That way we can call u ln of x, inside function, and y, outside function, log to the base of 4 of u. The derivative is derivative of y with respect to u multiplied by the derivative of u with respect to x. Derivative of u with respect to x and derivative of y with respect to u. Derivative of u with respect to x, u being ln of x, the derivative is 1 on x. I have a video on that too, but I'm not going to explain it here. Derivative of y with respect to u, log to the base of 4 of u equals 1 over u ln 4. Because you have log to the base of a number, and then you have your x, or your value, your variable, and then you end up with 1 over that unknown multiplied by log, natural logarithm of the number. Filling that in, we get derivative of y with respect to u, 1 over u ln 4 multiplied by the derivative of u with respect to x, 1 on x. What we end up with is just 1 over u being ln x, we have x ln x ln 4. How did I get this? Well, I multiplied x in, so it would be x multiplied by u multiplied by ln of 4. Then I subbed in u, so it ends up being x multiplied by ln of x multiplied by ln of 4, all under 1 obviously. And that's it. I hope this helps. Thanks for watching.